Hello everyone. Welcome to day 54 of learning data science. And till now, where we have reached is we have discussed about Python, we have discussed about EDA, we discussed about outliers treatment, export the data pre-processing steps, right? We have discussed all these things. We have come to outliers treatment. We also discussed about the 3 R's technique. Again, what are those 3 R techniques? I want to just write it down on the comment section. Obviously, the first one is rectify, reduce, retain. Okay. So basically, these steps are there in 3 R's technique. We discussed about winsorization. We discussed about trimming. We discussed about swamping. We discussed about five other things pertaining to outliers treatment, right? And also, we have covered the theory part. And now we were discussing about the data sets, covering those steps, right? And yesterday, we discussed the winsorization while using the IQR method, right? Again, what is IQR method? It's the same thing, the interquartile range. Interquartile range, what is IQR? Obviously, it's Q3 minus Q1, right? So we have discussed all those things, right? Today, what we will do? We will discuss the winsorization with some of the Gaussian method. We will also discuss with the help of what you can say, the quantile methods, okay? Quantiles method means, which I have told you, the 5% of data, we will be capping it, 0.5%. If not, just go and watch my day 50 video, you will understand what I'm talking about, what 5% of data, what 95% of data, right? So just go, definitely you will get your concept clear. Today we are talking about the codes, we are not talking about the theories much of the part, okay, right? So as you can see, means like I've already opened my spider here, okay? So my spider is already being opened. So first, what I will do, basically, this is a feature engineering concept, winsorization, outliers treatment. So we will just start with importing our feature engineering concept, right? So what I will do, uh, just give me a second. Okay, I will import feature engine. Okay, and now let's run whole of the thing. Okay, I've imported feature engine, and from feature engine, what I will be doing, I will be importing Winsorizer. Okay, from feature engine, import is the spelling right? Can you just check it? Okay, if not, I'll just check it with my Gemini itself. Okay, Winsorizer. Okay, our dot outliers, I've been writing those. Okay, basically here it will be dot outliers. And again, here will be Winsorizer. Okay. So basically, I've imported Winsorizer from my feature engineering outliers. So what will be my next step? Basically, we are trying to identify these outliers, treat these outliers with the help of Gaussian method. Okay. So with the help of, let me increase the font. Okay. Gaussian method. We are going to use that particular thing. So basically, I will define a variable name as W. Okay. And here I will write it Winsorizer. And yesterday I have talked about the capping method, tail, fold, basically what does this particular thing means, right? So I will write here capping method. Capping method is equal to Gaussian, okay, comma. I will use the tail both. Again, why both? I have explained it yesterday itself. Just go and watch my yesterday's video, okay? And why basically fold? Fold, if you have understood the outliers treatment, which we were basically talking about. So there, finding the outliers, I have talked about the three times. Means like when we are going to find some specific outliers, so it's the three times the IQR value, right? So for that particular thing, I'm writing here fold. Basically here fold, what does it means? Fold here basically means that what we are how many times we are multiplying our model. Model again, it doesn't mean whether we are using Gaussian, whether we are using some IQR method, or we are using some quantile method. Okay. So basically, these are the model. This is the Gaussian model we are trying to use to treat this outlier. For that reason, I'm writing here fold. If it would have been an IQR model, then ultimately I would have written 1.5. And if it would have been quantile, then I will write it 0.5, which is again the 5% of the left data and 5% of the right data. Okay. So I will be writing here fold is equal to 3. Then what's my next step? I will write here variables, my variables. Okay. And ultimately the variables will be the features which we are talking about. The features, what is that particular features? Obviously it's weekly sales, right? So we will execute this line of code, and when you will run this, then you can see it. uh, Capping method must be Gaussian. Okay. So if I will run this particular line of code, then you can see in my variable W, the winsorization have been installed, and we have successfully capped our values with the help of Gaussian technique, right? Now we will use quantile method, right? We will use quantile method. Again, what is quantile method? The 0.5, the 5% thing which I was talking about, whether it's left skewed, then the 5% of data, whether it's right skewed, then the 95% of data. So ultimately, sorry, my bad. So ultimately, if you look into what are those 5% of data, okay. So basically, when we are deciding about some left outliers, so if our data is left skewed, my outliers in my minimum, so what we will be going to do? We will be replacing those minimum outliers, the 5% of data, right? And if my data is right skewed, right? If my data is right skewed, so what I will be doing? I will be replacing my right skew data with the 95% of data, which is 0.5. Again, if we will subtract it, if we will subtract 95 from 100, then obviously it will be 5. And if we will subtract 5 from 0, then this is 5. Right. So basically, this is the concept, and I have already talked about in my theory part. Right. So we will be doing the same thing. Okay. I will be copying this thing. And in place of W, I will just write here, change my variable name W1. And in place of Gaussian, I will write here quantiles. Okay. And fold, I will write here 0.5. Okay. Why 0.5? Because it will be percentage. For that reason, I am taking 0.05. Right. If we will multiply by 100, then obviously it will be 5%. So what I will be doing, uh, writing it 0, sorry, my bad, 0.05. Okay. Then I will write here a comma. If I will run this, then obviously this is created, right? Now, what we will talk about, we will talk about the zero variance feature. So we will be talking about the zero variance feature. So what is basically the zero variance feature? Okay. So basically we are going to identify the zero and non-zero values within our features, within our columns, right? Okay. So what we are going to do, we are going to identify columns which contain a single value. Okay. And also we are going to identify the columns with a few unique values, example, less than 1% of our data. Okay. So if our data, which we are talking about the outliers, okay, and if our data is less than 1%, the few unique values are there, the outliers, which are less than 1%, then what should we do with that? And also, if our columns contains the single value, so for that particular, also what we'll be doing is, right? Okay. So if the variable is low, or I hope you are with your paper and pen, you are not just sitting idly on your sofa and just watching these videos, right? So what will happen? You will not get the things. So I hope you are with your pen and paper so that you can be attentive and not feel sleepy. So if the variable is low or close to zero, then a feature is approximately constant and will not improve percentile. Basically, it's not variable, it's variance. Okay. It will not improve the percentile. In that case, what we will do in that case, it should be removed. Um, so basically, in that case, it should be removed. Okay. So what we will do it, basically, we are selecting only numerical columns. Okay. Only numerical features. And why that reason? Because whatever mathematical calculations which we are doing it, right, we can't perform that with an string data type or with an object data type, right? We can't perform numerical calculation with this Winsorization service, with WINZ, right? Obviously, it should have some number pertaining to it, right? So for that particular reason, we will be considering the values which will be only numerical, right? Only numeric values should be there. Okay. So what I will do, I am selecting only numeric columns. Okay. I am basically selecting only numeric columns. So what I will do, I will write here n, and I will write df dot select d types. Df dot select d types. D types is basically my data types here. Okay. If not, just check it. If I will execute it, okay, here just above this, df dot d types. So you can see here, basically this is the data type. We are checking the data types. So what we are doing, you are doing df dot select d types, and what I will do, I will include np dot number. Did I import a numpy? Yeah. So basically in my n variable, if I will go into my variable column and if I'll open n, so you can see basically all those which is in numerical value, it came. You can see a date, weekly sales, not basically date because it is an object. Store is there, you can see weekly sales is there, temperature, fuel price, CPI, unemployment. Usually these all things came under, right? Now what we will be doing? We will be calculating the variance of each numeric variable in the data frame. Okay, so we are basically calculating that. Okay, so what I will do, simply I will just write it and dot var. And if I will execute this, you can see here, this is my variance. This is all my variance, particularly to this. And if we will check it, if our variance is zero or not, here, if you would understand, if the variance is low or close to zero or to zero, then a feature is approximately constant. So we will check that. And what we will do, we will check n basically is equal to 0, 0. So you can see here, everything is false. Why? Because none of my values were greater, were similar to zero, right? And what we will do, we will write again also one thing. We are checking the variance of each numeric variable is along the axis is equal to 0. Basically, axis means columns. Basically, axis means columns. Okay. Is equal to 0 or not? Is equal to 0 or not? So what we will do, we'll just write the same function here. Whenever we were doing n is equal to 0, so we were checking each rows. Here we are just checking the each column, the variance. Okay. So now what we will do, I will just execute the same thing. And here I will just write here simply axis is equal to 0 or not. Okay. So you can see here again, my values are 0. Okay. So this was regarding checking my each columns, whether we can decide to keep that particular column or not. Okay. So this was basically treating the outliers, handling it. So tomorrow, what will we learn? We will be learning the discretization. We will be learning encoding. Okay. We'll be learning rounding, binding, what all things are there. We will learn all those things. So till then, you just keep practicing it and see you in my next video. Till then, bye bye. Take care. Jai Hind.